Ladies and gentlemen, this is Dr. Annie Chen. Welcome to the class. Today the class is about Introduction to Energy Management System. I am Dr. Annie Chen. I'm from Datong University and the Datong Company. This is my profile for your information. Well, first of all, let's talk about the traditional grid. You can see that the traditional grid is the one-way power flow from the EMS to the bulk generation, transmission and distribution, and then to all the substation and customers. But in nowadays, in the new technology, we have the modernization of the grid. You can see that the traditional one-way power grid is getting smarter. Well, the DER, the distributed energy resources, is coming up, and the power flow become two ways. And you can see the intelligence infrastructure is coming up. So all the other loads, such as the EV, the electric vehicle, as well as the distributed energy resources, are coming into the whole grid. So you can see that that's integration challenges, and you can see the critical topics coming up: the innovation solution, technologies, and the grid architecture, and the cybersecurity, everything, and all the solutions become one topic. It's called AIoT. That will be the whole focus about the current status and the opportunities for us to study. And you can see the diverse focus on the smart grid development worldwide. We have the examples here from US, for EU, and for the Japan, and even for China. And you can see for the worldwide, we can see the same trend. The DER, distributed energy resources, are booming. And the AMI is significant, the so-called advanced meter infrastructure, the so-called smart meter. And also the smart control and communication is highly required in the whole picture. Now let's take a little look at the smart energy business performance here in Taiwan. We have the large energy storage system, we have the hydropower system, disaster prevention and the village system, and remote island system, and the household system for the electricity. And with the 70 years experiences in the manufacturing electrical equipment, and then we also complete the services and the product to the construction of transformer, meters, cables, substations, energy monitoring system, and the microgrid, and of course the energy storage systems. And then we also have the solar power, the smart meters, and the system solutions. Well, these are some other our performances in the smart energy businesses. We have the energy management and the unloading management, power generation forecast and unloading forecast, and the voltage regulation, and we also have the schedule management in the whole Taiwan land, even some of the overseas sites. And we also have the talent cultivation. The company work with the university, and we have the Central Research Institute, we have the business group, and we also have the College of Electrical Engineering and Computer Sciences. We try to combine and try to grow the talents, especially in the electricity area. And then we also let's take a look at the EMS introduction. The EMS is a computer tool which is used to monitor, to control, and to optimize energy generation, as well as transmission, and it also maintains the stability and the robustness of the grid. EMS is not only implemented in traditional centralized grid, but also applied in the distributed grid system. Distributed grid uses the microgrids of the renewable energy generation equipment, and is collected with the energy storage system to reduce the loss of the long-distance transmission and the risk of unstable power supply. So you can see we have the centralized and the distributed network. And in this slide, you can see that the Taiwan Power Company energy generation structure. Currently, the traditional centralized power generation, such as oil, gas, and nuclear power, accounts for more than 90%. But the centralized power generation is limited due to the environmental pollution, field social pressure, and other factors. So we are reducing that. So renewable energy can reduce the dependence of the energy, pursue sustainable energy, and enhance the flexibility and the firmness of the grid. You can see that the rapid development of renewable energy here. In terms of installation capability, the current stage in the development of renewable energy is focused on wind power generation as well as the solar. The capacity of the renewable energy installations accounts for approximately 15% for now, and it is increasing. And most of the excellent wind farms of the land have been exhausted. Wind power generation will be developed offshore. In the early days, Taipower took the lead in settling the several large-scale systems. Recently, the main development force has been moved to the private sector to achieve the goal of 1 million sunny roofs. The intelligence of microgrid is getting more and more important. The government plans to increase the supply of green energy in the future, exceeding 20% of the total energy supply. Green energy power generation includes solar power, hydropower, and wind power, and so on. The type of power generation has a certain seasonal cycle and instability, so electrical vehicles have an increasing influence on the supply and the demand of electricity. The meter consumption data of the smart building will become one of the foundations for future Taipower demand response forecasts and the related architectural. In this slide, we can see the wind drive generation's developing program. This is the plan for the Taipower in the offshore wind energy. And this is the development of solar power for the past few years. You can see that from the private sector and with the Taipower, and these are the yearly accumulated power generation for your information. And now we can see that the applications of the EMS. The utilization for the EMS are the four purposes. The first one is the monitor and the control. And then we can optimize the efficiency of the power generation, transmission, and consumption systems. And of course, it can do the data visualization and analysis. And also, it maintains and the operation management of the power equipment to optimize the efficiency of the power generation, transmission, and the power consumption systems. And here are some issues to be considered in the EMS development. First of all, the data security is very important. And of course, the clear information and a stable system. And the system planning flexibility, simple to use. Of course, it has to be friendly. And last but not least, it has to be customizable. The energy monitoring management, here we can see that there are several levels for the management. The very first one is the factory, the company, the community, building, and family. The data has increased by more than 10,000 times compared to 15 years ago. The systems and the standards management in the company. Now you can see that the decentralization and the miniaturization of the power generation area, the grid is getting smaller and smaller, although the renewable resources like the solar power, wind power, tides, and the geothermal power are inexhaustible. But they will still have their own regional restriction, so they have their own suitable construction sites. The sites are limited. So in response to the different requirements of the disaster prevention, the village, the region, the microgrid and distributed grids are booming up. In this picture, you can see the layer response design. Of course, very first of all, we can see the cloud. The cloud is doing the business decision, the big data calculation. And the fog is a little lower. The local internet embedded automatic controller conducts logic responses. And the edge, sometimes the edge computing is working in the gateway or the modem. And the edge is working on the real-time responses, such as the emergency incidents, and the easy calculation and the data filter. And in the very, very lower end, there will be the sensors. The sensors are doing the data collection. So we can see that in the traditional IoT structure data processing method here, we have a cloud up there, and we have the embedded system down in the ground, say the sensors. So we send the data up, and the cloud send a command or the control signal here down to the devices. So they are the sensors, the gateway, and the cloud. But in the current time, we have the cloud fog calculation IoT structure. So you can see that we have the OS here, the edge computing there, and the cloud. So some of the work is doing in between in the edge. So it lower the computation, and it also lower the load, the demands from the sensors. Yeah, so the data and the command is coming more frequently and more fluently. And here are the 4 issues for the cloud fog calculation. You can see that there are the 4 issues: the latency, the bandwidth, the connectivity, and the privacy. These are the 4 very big issues for the cloud and the fog calculation to be focused. And there, now we can see that in the grid, there are many data resources. The very first one is the AMI. We have the signal and the data from the meters and the grid sensors. And of course, we have the data from the renewables and the distributed energy resources. And we also have the data from the untraditional resources, such as the IoT equipment, the home energy management system, or the electricity vehicle charging stations. So nowadays, we have a lot of data resources in the energy area. So we have to integrate the distributed data storage pool. You can see that according to the area division, the grid-related signal databases, we have the SCADA system, we have the outage management, we have the customer relationship management, we have the billing management, and we also have the work management. And here we have some customized system. The disaster prevention system, village power supply system, remote island microgrid system. We also have the AFC, the automatic frequency conditioning system, and of course the UPS. And there are some innovative technology participating in the utility service and the energy area. The very first one is the blockchain, and the machine learning data, big data analysis, and the AI are also applied in the energy area. And the renewable energy is coming up, and the micro power generators, and of course the new transmission techniques. Yeah, and let's talk about some the new technology application. For the AI, we have the prediction generation and the consumption, and we also upgrade the energy transmission and the utilization efficiency, monitor equipment and predict failure, and the building and the family energy saving, and of course the peer-to-peer energy transaction market. These are the new technology coming up in the application. And then we can talk about some AI applied to the utility services. The edge device calculate optimal path to reduce the transmission delay and increase the forecast accuracy and enhance power grid stability. And the AI also can help to control and management the input and output of electricity vehicles and enhance the energy utilization scalability and efficiency. Now we see some distributed microgeneration is not easy to control. Certain types of DMG, the so-called distributed microgeneration, have higher power generation variabilities. Since 2012, the wind power generation in the United States has increased by 40%. The increases in wind power is because most of the DER do not follow the dispatch signal, and operators usually do not see these distributed energy resources in the system. So a large amount of unexpected energy supply can lead to system inefficiency and cause unnecessary circulation and other power generation equipment. Although some grid operations use complex forecasts and create greater balances to balance the charges, the changes in the power demand, but other operators do not have the infrastructure. So operating practices take another to portfolio or regulatory structure to make these improvements. Smart contracts can improve transaction efficiency. Smart contracts can be triggered manually or automatically to improve efficiency and can respond to demand locally. Smart contracts can automate the power transaction between parties in the ecosystem, thereby realizing the automatic exchange of the power. These advanced applications and grid design have improved the optimization and power supply and demand balances. Now we can see the established blockchain energy platform to gain advantages, create some future energy market. At Atlantic Power Exchange, they built a blockchain-enabled peer-to-peer energy exchange platform to empower the DMG and encourage investment in the renewable energy. At Atlantic Power Exchange, such as future energy market is being created to allow the adoption of more distributed microgeneration technologies that can increase the energy resilience while providing the energy users with real energy options. This will allow energy producers and customers to interact directly. Blockchain can also can solve invisible problems of power generations. And they provide energy visibility and the transaction information. Blockchain, if it is implemented properly, can provide unparalleled visibility and the tradability of energy. And with arranging the fragmentation of the electricity market, it can simultaneously meet the complex requirement of the grid operation. DMG owners can easily access the blockchain, thereby facilitating electricity transactions. The integration of power grid and the utilities and the use of the blockchain-enabled distributed microgeneration units can create a trusted and a secure system for managing transaction and distributed resources, including the DMGs. This enabled the grid operators to obtain information, providing them with a detailed visibility to effectively manage the loads to ensure the reliable and uninterrupted power system reliability. Now we can see some challenges of the electrical vehicles. EV include, but not limited to, the roads, the railway vehicles, or surface and underwater vessels. The tradition is mostly based on the oil design, Because of environmental pollution and the oil inventory concerns, the possibility of using vehicles with other power sources have been studied, and the technology have been gradually matured. The number of customer electric vehicles is increasing, and the demand for electricity and electrical vehicle continues to grow. However, the characteristics of the charging time and the location, which is difficult to master, make it a challenge to manage and to. Okay, now let's see the predict the EV impact. Well, it will occur. When the EV penetration has increased, operational planning requires continuously updated forecasts of charging patterns that are overlaid on the grid models. So that will help the operators to predict where the EV impact will occur and adjust for it. So we know that the ADAS automatically calculates distribution overloads to provide operators visibility of the travel area in order of the priorities. So providing the incentive to customers to charge. So we educate the new customers to minimize the impact of the EV charging on the grid by providing the incentives to the customers to charge when power resources are available. And utilities need to educate their customers and make it easy for them to participate in these types of programs. So you can see that we have to lower the price, we have to educate our customers, and we have to minimize the impacts. So response from power companies. It is difficult to obtain the general customers' vehicle models, charging time, and other related information. Therefore, we provide flexible electricity price measure, register relevant information, and the electricity price discounts during low load time to attract customers to charge during the low peak hours. So we also accumulate the customers and the charging data and analyze the large amounts of the data and the models to predict the charging demands. And of course, the company has to build more energy storage equipment to increase the stability of the grid and deal with the fluctuation in the supply and the demand of the renewable energy and the power vehicles. So the demand of fortified grid in the cost-effective ways. In the early stage of the grid, the planning for the EV adoption, utilities need to forecast EV demand and its impact on the ground to the grid. Develop cost-effective ways to fortify the grid and make recommendations on how utility investment will be compensated. A distribution model at the feeder level is needed to accurately determine where and when the grid will feel the charging impact. So the existing GIS-based connectivity models are not enough anymore. So we can see some AI in the EMS. Infrastructures such as smart meters and smart grid will affect the integrity of the data collection, help the efficiency and the transparency of power management, and increase the possibility of using the renewable energy. So use data analysis capabilities to optimize the management. And the automation of AI system is particularly effective when operating routine and structured tasks. So we have some introduction of the big data analytics here. There are 9 steps of the data analytics. The very first one is the business case development, business case evaluation, and the data identification. Then you have to do the data acquisition and filtering, data extraction. Then you have to do the data validation and cleaning, and the data aggregation and the representation. And finally, you come to the data analysis. You have to do the data visualization, and somehow you will have the utilization of the analysis results. So we can see the business model evaluation. First of all, we have to clearly understand the motivation, the purpose, and the reason why we will do the analysis. So you can see that you have to know what you're targeting. And then we will do the data acquisition. The first one is the data set confirmation. It is necessary to first find out which data sets are needed for this analysis purpose and their sources. And the acquisition and filtering the data. Collecting this data and filtering these unwanted data. And then we'll do the data extraction. We need to extract and convert the data first, and then transform the data format into the data format that we can be processing and analyze. Then we'll do the data cleaning. The data certification and the cleaning are doing the same. Establish the certification specifications and remove unqualified data to increase the data quality. And then we'll do the data aggregation and the reorganization. We will have to combine the different data sets. So in the step 7, we will do the analyze the information. So data analysis, the actual data analysis task is carried out at this stage. Combine data mining and the complex data analysis techniques to discover the meanings of the different patterns and the relationship between these variables. Then we come to the use of data. We have to do the data visualization. You can see that the pie charts, the bar charts, and the triangles, these are all the data visualization. Use data visualization technology and the tools to graphically display the data analysis results to the users. And then we will have the utilization of the analysis results. So we will focus on the deciding how and where to use the analysis results, which can be the greater influences. Sometimes we call that business intelligence. So there are some different types of data. In this page, we see some unstructured data. Data is the carrier of information. Another term for experience. It can be provided in the structured or unstructured type. So you can see that the image, the voice, the text, even the chess record. They are all the types of data. So the unstructured data includes the text, picture, voices, videos, and so on. And these unstructured data are learned and classified through the deep learning and the reinforced learning, this method. And also, of course, there are some data structured data. So the machine learning data, the machine learning model mainly uses structured data. That is two-dimensional data tables. Unstructured data can be processed and converted into structured data, such as reshaping the pixel tensors in the picture data into the one-dimensional array, or the text data into the two-dimensional array using one-hot encoding. So these are the examples for processing the text data for your reference. And this is the example for processing the picture data. They take a picture into pixels, into the color information, and reshape it into the vector. And then now let's take a look at the so-called IoT. There are 4 elements of smart IoT. The human being use the brain to translate and then receive data into usable information. But for the IoT, the process of the translation and origin data into information is required. In addition to the necessary network and communication infrastructure, there are 4 basic elements that constitute the smart IoT. They are the sensors. That's where the data from, and the collected data, and the show information to display the information, and finally somehow the data analysis. So we have to refine the knowledge. So we have to transfer the knowledge, the data into the information, to the knowledge, and finally to the decision. Well, in this page, you can see some smart technology to help you save the energy. There are the smart thermal, smart zoning, smart window control, and all the modern technology to make your building smarter. So we can see the smart buildings coming up technology. A building must be used for more than 30 to 50 years at any time. So due to the various factors such as the background of the times, social concepts, related technologies, and construction processing, a series of modern smart buildings occurred during the construction week that we built 20 years ago. And the urban design and the various related concepts are coming up. In today's smart buildings, various sensors are installed to collect various relevant information, including a person's various resident needs, such as general household electricity, the water, the gas for the cooking and bathing, indoor and outdoor temperature and the humidity measurement, and so on. In addition to understanding the energy consumption, which is currently used, we can also perform the manual remote control of the equipment and even achieve automated control. So the BEMS impact on productivity and health. According to the EPA report, people spend about 90% of their time indoors. Therefore, maintaining a comfortable temperature and good air quality are very important, which will have a significant impact on productivity and health. So indoor air pollution is sometimes 10 times more than outdoor. So the BEMS, the Building Energy Management System, can help to improve the indoor environment by controlling and monitoring their ventilation rate, indoor temperature, and the humidity, and lighting. So there are studies show that the improved lighting can reduce the dependence and the incidence of headaches by 27%, and the improvement of the indoor environment can increase the performance of American workers, reduce the total health bills to the 1.7 to 48 billion, and increase the profits by 20 to 16,000. So U.S. Green Building Council reported a better environment allows students to make 20% improvement in mathematics-related subject and a 26% improvement in the reading-related activities. So now you can see that the integration of equipment and the communication is challenging. How the infrastructure can be smoothly coordinated with existing lifestyle to make effectively use of their collected information. Distributed equipment and the sensors are handled during the fault maintenance. So each hardware device has their own communication protocols, data storage method, code requirement to obtain and control the equipment method, project design, construction, and the cooperation of the household. So design, work items, and communications are different for each buildings. And there is no uniform standard to follow among equipment supply manufacturers. So therefore, a single manager cannot have a complete knowledge of the entire smart city and the architecture. Although the verticals, such as the IoT, have been vanished from very years, network speeds up the connection. Network speeds and the connection method are interrupted, and the various communication protocols are scattered, and there is no unified standard, which increases the difficulties of the building system and promoting related applications. This is the picture of the building automation protocols for your information. You can see the IoT, the BACnet, and the KNX. And there are several layers from the physical layer, data link, network, transport station layer, presentation layer, to the application layers. So the different segment network need to be connected into the building. The different protocols of the subnet integrate into the SCADA network. So the office network is connected to the SCADA network, and the firewall is set up for the information equipment to monitor the security issues. And this is the picture about the smart meters evolution. At the present, high voltage users have been converted to smart meters, and the household and the low voltage users have gradually converted, helping us to progress from manual meter reading to the past to the communication meter reading system. Because of the use of smart meter systems, we can apply dynamic electricity prices to users and display the information in real time on the web pages and the applications. So smart meters can also monitor, control, and report various events. So you can see at the picture we have the machine meters and the electric meters, and then now we have the smart meters. Electricity and the related data collection. Popularization of the smart meters is the first stage of the infrastructure for the smart grid. So smart meters are not enough. Whether the network connection can be smoothly transmitted, whether the delay is low enough, and whether the bandwidth is sufficient to meet our data transmission needs. So in order to ensure that we understand the equipment status and connection status of the and at the edge of the network, we need to set up data collection devices, say the aggregators systems. At this time, some situations that require low latency and a fast response can be controlled and responded by the data collection device. It is best to connect to the data collection device to a trusted network and use the cloud or other devices to monitor and to ensure the connection and transmission are stable. And this is the communication architecture diagram of the household smart meters. The smart appliances are connected to the smart meter through the home network, allowing users to grasp the power consumption and the various conditions of each appliance. So the meter is connected to the regional data concentrator, where the simple control and the calculation can be carried out, and the data can be transferred to the control center and the meter data management system. The evolution is a history of the mobile communication technology. So we can see that the United States Wireless Industry Association, so-called CGIA, pointed out that the 1G only has the 2.4 kbps transmission speed, but it has taken a big step forward, breaking through the past fixed point phone call restriction. So the 2G rate is coming up between 56K to 114 kbps, realizing the digitization of the voice communication and the transmitting text context through the small screen of the mobile phone, opening a new area as the SMS. So when the 3G comes up, the 3G standard was officially announced in 2000, and has a rate of 384 kbs, allowing users to browse the websites and stream music. The stable speed brought by the 4G is considered to be the driving force of the application economy, and it is also drives the development of the social websites. So the 5G communication technology is coming up. The 5th generation mobile network is here, abbreviated as 5G, referred to the 5th generation mobile communication technology, which is extension of the 4G system. And after 40 years development, the mobile communication finally reached the so-called 5G. And the innovations in the network communication technology appear on average every 10 years. So new network communication technology has brought people a lot of changes in life and of course in the industry. So in 4G and 5G, the bandwidth, the latency, the rates, the coverage are totally improvement. You can see in the picture. The 5G Internet for characteristics. 5G will be faster, smarter, and more power efficient than 4G, making it easier to use with a variety of new wireless devices. The 5G will make smartphone faster, give birth to the smart public facility and the smart resident devices, and extend the standby time of the wearable devices. We at least know that the speed of 5G network will increase tenfold, and compared to the network speed, ultra-low latency will be the cornerstone of the innovative 5G network applications. And we can see some characteristics of the 5G. The 5G communication devices are characterized by high data transmission speed, reduced data reading delay, cost reduction, energy saving, increased device capacity and connection of devices. The frequency spectrum is flexible, and the optimized millimeter wave spectrum can provide 10 gigabits per second throughput, 10 times of the current 4G technology. And ultra-low latency, the 5G can reduce the transmission delay to 1 millisecond by changing the confirmation processes. Network slicing meets the specific application requirements, support general mobile customers and corporate private traffic, and provides a secure space for storage, sharing, and analyzing data. So energy efficiency, 5G can reduce grid power consumption when transmission is not in progress, reducing the operation costs. So you can see that in the picture, the satellite system development towards integration with the ground mobile communication system. Well, in these slides, we can see some the infrastructure for smart grid is gradually progressing. In order to achieve the goal of energy saving and promote the transmission to low carbon energy, AMI, the so-called advanced metering infrastructure, is one of the important tasks. The smart power grid is a large-scale comprehensive project that requires a lot of time and efforts. The infrastructure of the smart meters is composed of smart meters, communication systems, and the meter information management system. It is the most important construction for achieving the goal of the smart grid. Currently, Taiwan high voltage users and high power users have been updated to smart meters. The next step is to gradually replace the buildings, shopping malls, and even general household users. It is estimated by the year of 110, there will be 1 million low voltage users with electricity prices, which can reduce the peak load of the 275,000 kilowatts of electricity, which is equivalent to saving one nuclear plant, 40% of the power of the units. The home energy management system, the home power consumption data detection and the data transmission to data collector and the management system. The electricity consumption data of each smart home appliances is displayed on the app and the web page. After the control center obtains the energy usage data of the household users, it can be analyzed and make decisions based on the electricity use data. Smart meter attack scenarios. Users alter the electricity consumption of the meter to avoid high electricity bills and change the electricity consumption to lower a numeric. So external malicious personnel increase the power consumption, causing users to incur unnecessary expenditures. Attack method 1, the route A attack from the power company side. The 2, route B attacks from the household HEMS side. According to the FBI 2017 report, hackers continue to try to attack nuclear power plants and energy equipment companies, as well as the factories in the United States and other countries. The frequency number of the attacks has clearly increased. Smart meters are hypothetically victims of the current cyber attack. This one is the future home energy management scenario. You can see that the HEMS here, they collect data, they make decisions, and then execute the orders. So in the whole scenario, we have the PV solar, the lighting, the smart appliances, and your mobile and the computers. And we have the storage system. We have the EV cars here and the smart meters. So we're adapting the predictive energy models here, adjusting the energy consumption of the building through changes in the energy prices, weather changes, and the information inside the building. So utilize the structure of the building itself or its own solar power generation to reduce the summer and the winter loads. And based on the past data, the model learns, compares, and adjusts its parameters. So you can see in the picture here, we have a cloud-based platform for decision support and the building energy management. So we have the users here and all around to the constructor, to the funding stakeholder, to the management holder, and also to the grid. And then in this picture is the example of the visualization of energy consumption. You see the red ones, that mean the red zone for higher and more energy consumption here. And then we can see that the data analysis help us to do the preventive maintenance. So take the solar power plant as an example. Collect the historical power generation data of various inverters in different sites in the past. And we will compare the current data so it can be found out manually from the graphs and the machine learning models to understand the weather, and there will maybe the abnormal operation conditions. And the maintenance personnel are invited or to demanded to the site to understand the situation. And then we also record and understand the power generation equipment problems and classify and try to analyze the possible causes. So we re-monitor the status and existing equipment to see if they are the same problems. So you can see that in the process, we have the data collection, the modeling, and we find out the problem, and then we make the decision to see the abnormal of the problem, and then we correct it and optimize it, and then we do the data collection again. It's a cycle. So we can see that the system data from the solar power curve. These are the examples. The very first one, we can see the smooth curve, the normal power generation of a sunny weather. And the sawtooth curve, the cloudy and the rainy situation. And the third one, the curve break communication problem, system failure. You can see that the curve here, we have a drop up. That means that part can be disconnected. And the very, very lower one, the shading of the roof and other reason shows a downward curve. So these are some examples we have for the solar power curve. Then we can have some example about the data visualization. The basic mathematics, say the trigonometric function, linear algebra, geometric algorithms, or the graphics, the canvas, the computational graphics, graphical theory, or the engineering algorithms, analyzing information, say the data cleaning, statistics, and the data modeling. And we have the design principle, how beautiful it is, the color, the interaction, the cognition, and the visualization basis, the visual coding, the visual analysis, and the graphical interactions. And finally, somehow we have the visualization solutions, the correct use of the charts, the common business visualization scenarios. And so we can use the data visualization to increase the process efficiency. So the amount of the information that human can visually obtain far exceeds than other organs. So visualization can explain that we process more complex information and enhance memories. So you can see that we have the table or we have the charts. So the utilities can effectively use data. The maintenance team of the energy management system can judge the situation and deal with it appropriately based on the historical condition and the visual information. So frequently occurring problems can be marked and handed over to the automatic system or data analysis team for further analysis and processing, establishing appropriate judgment and the data processing models, and continuously optimizing the judgment and models. These control judgment can be developed to different network levels. So data analysis can also help companies make business decisions, help the company reduce expenses and maximize the revenue. So this is the example for the visual charts to help business divisions. So you can see the pie charts, the bars, and the percentage, and the distribution, as of course with the dollar signs. Well, it's our conclusion today. The EMS have different uses in different fields. Due to the development of environmental awareness and smart energy, it has gradually changed from electric power companies, manufacturing industry, and building to management system commonly available in ordinary household. The current infrastructure is not completed, so a complete smart grid takes time. The development of the renewable energy and the electric vehicles has promoted the process and intelligence. Many power companies are already trying to apply 5G networks, blockchain, and AI to the power grid and promote different applications such as tradable power platforms. And a large amount data analysis help the business decision making and will help the development of AI in the energy field in the future. So thanks for your time. Thank you.